got a very pale green colour in, as you can see, okay? So when I take some of this and pour it into here, it's a very, very pale green. Okay? There's a magic change and it turns from purple to colourless. Okay, that's acidified permanganate reacting with iron 2 plus. Okay, of the not chromate,
iron 2,
dichromate,
chromium 3. Yeah. Okay, and it's green slash blue, teal. Notice the difference in what you can see here and what you can see on the screen. Alright? I think that is the colour oxide. That means it produces 20 volumes of oxygen for each volume of H2O2. So it's quite strong. And there's also effervescence in there. You can't really see it where you are, but there's lots of bubbles in there as well. Okay? It's moving too fast, actually. Okay? There's lots of bubbles. What are those bubbles formed from this?
hydrogen.
Make sure your brain is engaged in here before opening your mouth, not hydrogen. Alright? Okay, so warmed oxalic acid now. No, it's still a slow reaction, okay? But it might be quicker than... I should. And if this doesn't work, that's what I'll do. Because heating them both up will increase the collision, increase their kinetic energy, and increase the rate of collisions between both particles, won't it? Okay? Like what?
Throw in some more magnets.
Throw in some more magnets. You think the magnets have some effect on them?
Yeah, a lot.
Really?
How did your flag your flag is married?
Oh, so I can use the keyboard with the macrons on the top.
Macro.
Macrons, line over the top? You think that's changing?
No.
Oh, I do.
Yeah, I see it.
Slight change.
Well, if Bailey sees a change, there must be a change because Bailey is all seeing. Yeah, now look.
Yeah, boy.
It's actually changing through a different oxidation state. Actually, that one there is something like manganese 5 plus, that red colour. That's not important for what we're doing. But I think we will do it again at hot with both of them heated up. Oh, look.
What?
Don't be too big.
Is that like yellow? It's just a pale library. The vortex in the middle, can you see the vortex in the middle? If I actually, I could stick something down there which won't even get wet. Yeah. Well, my finger won't fit. If I do it, I use a big beaker, I can. Right, it's going right through to colourless, which is Mn2+. In fact, you can see, right from permanganate, you can see a range of colours on that one. It's quite good.
Can you increase the speed, sir?
I can, but I'm not going to. And we'll do that again in a moment. I'll heat up both ingredients, all right? This time, both solutions have been heated up. Okay, both solutions have been heated up. So here's oxalic acid, there's the permanganate, ready to go. Whoa! Alright? So, colourless solution. Okay, very quickly that colour is produced. That colour is the same colour as stuff here. What's the label say? Iodine. So iodide is turned into iodine. It's magic. The brown colour is disappearing. That means the iodine has reacted, okay? It's actually the reverse of what it did before. Before, iodide was oxidized to iodine. This time iodine is being reduced to iodide. What am I putting into it? Potassium iodate. This is potassium iodate. It's also a colourless solution. And straight away, immediately, instantaneously, there's quite a reaction, and we've got a dark brown solution and a kind of blacky solid formed in here. Okay, this is the weakness of using projection machines, which not HD. Okay, potassium iodide will be written right. That's a good example of a slow reaction. This one, okay, because you get a process which is.
That's pretty. It was clear yellow, then it turned solid.
Yes. That white precipitate is copper 1 iodide, CuI. You need to write that down. Copper 1 iodide, CuI. So the two products in this one, which was number copper sulfate, potassium iodide one, whichever it was. Number 8, was it?
8, yeah.
Okay. The two products are the iodine solution, which is the brown colour in the solution, and copper 1 iodide, CuI, which is the precipitate in the bottom. Okay. Okay, potassium iodide solution is colourless. So that I'm adding chlorine water. That's chlorine, Cl2 dissolved in water. So it's an aqueous form of chlorine. Okay, and once again I get the same brown colour, which is due to iodine. So iodide, listen, iodide has gone to iodine, so chlorine has gone to chloride. Can you see a brown colour on the top of the bottle? That's a bit of NO2 coming off that as well. But as soon as I do this, I'm going to get a lot more NO2 produced. Okay, the gas is starting to be produced in the bottom there. Alright, brown gas is being produced very, very quickly. There's a green solution in the bottom of here. Okay, you can see the green solution in the bottom of here. I'm not letting that gas get out the top. Okay.
Can you do that again, sir?
No. This gas is heavier than air, that's why it doesn't want to get out of the beaker.
Oh, it's coming out.
Ah, yeah.
No, it's not. No, it's not. Yes, it is. Can't you see it?
Cameron, get out. Is it poisonous?
Oh, she!
Yes.
Oh, so you can't smell it.
I don't want to smell it.
I was just saying.
Colour looks pretty similar to the colour of the iodine we've been producing, but it's not. Different chemical. And we're going to add to that potassium iodide. Is this the last potassium iodide one? Yeah. Good, because I'm nearly out. Okay, again, we've produced a brown colour which is caused by iodine. Okay, so iodide has been oxidised to iodine, so Fe3+ must have been